want to talk a little bit about the MUF paper and maximum urgency first, because it's important to go over laxity and how we compute that. And in fact, you have to recompute the laxity at every heartbeat. Because remember, the heartbeat, we'll talk about this a little bit more later, but the heartbeat of the operating system is the point at which we recompute and we do a reschedule, recomputing schedule priorities. Now, I got a quick example I'm going to show. Whoops, there we go. A quick example I want to show for two simple tasks and how we compute laxity. Imagine our timeline going from 0 out to whenever, and we have one task that is running at 10 milliseconds, but it takes 7 milliseconds to run. And we have another task running at 7 millisecond period, but it only takes 1 millisecond to run. Now, what's going to happen with these two tasks as to compute the laxity? So we draw our normal initiation times for task 1 and task 2. So this is every 10 milliseconds. So there is another release time here. And then for task 2, it's every 7 milliseconds, so it has another release time right here. Okay, so there are two release times, and so the question is, when if we're back here at time 0, then how do these two tasks fit on this timeline? And that's what the laxity calculation is. It's how much leeway do we have in terms of laxity? How much leeway is there that this can fit? And you can see, so it is, the laxity of this is just 3 milliseconds. That's the difference. So laxity of 1 at time t equals 0, because that time is important, is just 3 milliseconds, right? Because it's the deadline, which is 10 milliseconds away, minus the execution time of 7, so that's 3 milliseconds. Now, likewise, we're going to take the T2, right? It has, its deadline is here at 7 milliseconds, but, you know, it can fit anywhere in here. And so its laxity is 6 milliseconds, right? The laxity of task 2 is the deadline, which is only 7 milliseconds away, minus the execution time of 1, so that's 6, right? So we're naturally going to start task 1 first because it has the minimum laxity, okay? So task 1 starts to execute. We're not executing task T2 yet, right? Because task T2 is now lower priority. This sets the priority. And now, the thing is, we have to periodically recompute as time progresses, we have to recompute the laxity. And this is important because we have to keep in mind, and this is where the error in the paper is they fail to mention this, or they say that it's not recomputed. Because as you move through, imagine here at time t equals 2 now, there is not as much of task T1 is 2 milliseconds is all used up. So I've indicated that here with the shading out of the first 2 milliseconds on task T1, which means now the laxity, if you can see at T2, there's only 5 milliseconds left of execution time, and the deadline is still at 10 milliseconds, but that's 8 milliseconds away. So 8 minus 5 is 3. So the laxity for task 1 remains at 3 milliseconds. Okay? But the laxity for task 2, now from position time 2, we look and see that the deadline is only 5 milliseconds away, and the execution time remaining on task 2, which hasn't started yet, is 1 millisecond. So 5 minus 1 is 4 milliseconds. So the new laxity of task 2 here at time t equals 2 becomes 4. Still larger than the laxity from task T1, until we then move to the next position 4 here, and sure enough, as we compute, we see the time now 4 milliseconds has been consumed of task 1, but there are 3 milliseconds left. And the deadline is 6 milliseconds away. So the laxity for task 1 now is 3 milliseconds. And of course, the laxity for task 2, which is only 3 milliseconds, the deadline is only 3 milliseconds away, but there's still a millisecond to go. So now the laxity is 2 for task T2. And so what we see is we switch and let the task 2 run, and of course it's going to run to completion after only 1 millisecond, and after that we are going to let task 1 finish the remainder of. So that is the bug that was in the MUF paper, and that they don't explain properly state that the reschedule does have to recompute the laxity. As you can see, for the task that is executing, the laxity stays constant. But the other tasks that are not executing, they may be updating. That's how you compute the laxity in minimum laxity first or in maximum urgency first.